1, pages 43, 44, and 49. The mean, median, and mode are known as measures of center or central tendency or location. Again, consider these 12 exam scores ranked from smallest to largest. The top row is the ranks, 1, 2, 3, 4, etc. The bottom row is the exam score, 28, 59, 65, and so forth. We want to find the mode. The mode is the most frequently occurring exam score. There can be more than one mode. If each data value occurs only once, then there's no mode. So in this set we have the score of 88 occurs twice, so that's the most frequently occurring score. So the 88, the answer here would be 88. Another measure of center is the median. The median is the middle number or the average of two middle numbers. It's the same as the 50th percentile and the second quartile. In this case, for this data set, we have an even number of exam scores, so there's going to be two numbers in the middle, and we want to take the average of those two. It would be the average of 82 and 83. So this is the mode here is 88, and this will be the median average of those two. So it's going to be 82 plus 83 divided by 2. That's 165 divided by 2, and that'll be 82.5. Okay, so that's the median. Another measure of center is the mean. The mean is computed by adding up all the scores and dividing by the number of scores. For some purposes, it will be useful to express this as a formula, mathematical formula. So we'll use the Greek letter capital sigma, uppercase sigma, to mean sum. And this below the sigma we have k equals 1. That means as k goes from 1, and at the top we have n. So it's the sum as k goes from 1 to n. X1 represents the first exam score, X2 represents the second exam score, and so forth. N is 12. We have 12 exam scores. X with a bar on top, X bar represents the mean. So the summation as k goes from 1 to n of xk all over n. N is 12, so it's the sum as k goes from 1 to 12, xk over 12. So it's x1, which is the first exam score, plus x2, plus x3, the third exam score, plus x4, and so forth. So we add these up. These all add up to 923, and then you want to divide by 12. 12 into 923. 12 don't go into 9. It'll go into 92 7 times. 7 times 2 is 14. Carry the 1. 7 times 1 is 7, and 1 is 8. Remainder 8. Bring down 3. 6 times 12 is 72. Remainder 11. We'll get a repeating decimal. Eventually it'll repeat. So 8 times 12, 8 times 2 is 16, 8 times 1 is 8, and 1 is 9. Actually, that'll probably go 9. 9 times 12. 9 times 12, 9 times 2 is 18. 9 times 1 is 9, and 1 is 10. Remainder 2, bring down to 0. 1 times 12, 12, down to 0. Okay, remainder 8, bring down to 0. 12 into 80 goes 6 times, and we'll get repeating 6s. So it's 76.916 and repeating 6s. Okay, so that's the mean. So it's approximately 77. We'll say approximately 77. The mean and the median are the most commonly used measures of spread, especially the mean. The the nice thing about the mean is that there's a very strong relationship between the mean of a sample and the mean of a population. And when we're gathering statistics, we always want to think about the connection between the sample and the population. Okay, there's an outlier of 28. 28 was less than the other exam scores, and it brought down the mean. You notice the mean is lower than the median. The median was 82.5, and the mean was about 77. So that one low exam score brought down the mean. So the mean is affected by outliers and skewness, whereas the median is not. So the median is called a resistant statistic. So that's the advantage of the median. It's not affected by outliers. And the fact that the mean is less than the median indicates the data is skewed left. Sometimes it's useful to find a weighted mean. Frequently in classes, the final exam is weighted more than the other exams, and also later, if you continue to take statistics, in the more advanced courses, we're weighting events by their probability. So there's a weighted mean shows up in statistics, and that is a probability. But anyway, so we want to find the weighted mean if the first exams are each weighted 5% or 0.05, and the final exam is weighted 45% or 0.45. So for the weighted mean, we want to use the original order, and so usually the weights add up to 1. So if not, we'll use a slightly different formula if they don't add up to 1. But usually the weights will add up to 1, and the formula is the sum again. Sum as k goes from 1 to n, and each exam score times its weight. So that's k times wk. And again, sigma means sum or total. Okay, so basically we want to multiply each exam score times its weight, and then add up the results. The first exam was 80, its weight was 0.05, 80 times 0.05 is 4. Second exam, 88, and the times 0.05 is 4.4. 28 times its weight, 0.05 is 1.4, and so forth. And so it's each score times its weight. At the bottom here, I left a couple of blanks here, so this would be 89 times 0.05, and 89 times 0.05 is going to be, and then I have 45, 8 times 5, 40, 44. And so that's going to be 4.45. And then we have 82 times 0.45 is the last one. So 82 9.45. 2 times 5 is 10, carry the 1. 8 times 5 is 40, 41. 2 times 4 is 8. 8 times 4 is 32. 0, 9, 6, 3. 36.90. So this is 82. 9.45 is 36.90, and then we want to add these up, these 12 numbers up in this last column, and it comes out to be 78.95. So we see that because the final is weighted higher, and the final exam was a little bit more than the original mean, so it brought the weighted mean up because it was weighted more, and it was more than the original mean. Okay, so there's mostly we're going to be using formulas, but in the more advanced statistics courses, you'll be proving formulas. So we'll do a little bit with proofs here. Not a lot with proofs, but here this theorem here says that when exam scores are weighted equally, with the weights adding to 1, the weighted mean is always the same as the original mean. Okay, so in symbols, we want to show that the summation as I goes from 1 to n, xi wi, is the same as summation I equal 1 to n of xi all over n. I could have used I or k. I happen to use I here, but the index, I is what's called the index, and it doesn't matter if we have an I or a k there. Okay, so usually when you do a proof, you start with the left side and try to manipulate it until you get to the right side that comes out to be the right side. So the summation as I goes from 1 to n, xi wi, that's equal to the summation I goes from 1 to n of xi times 1 over n, and that's because we're assuming the scores are weighted equally. So if we have n exam scores and they're weighted equally, then each weight is going to be 1 over n. Just like if you have a pizza and you divide it among 3 people, then each person gets 1 over 3, right? Or if you have a pizza and divide it among 17 people, each person gets 1 over 17, or 1/17 of a pizza. In this case, we're weighting exam scores equally. There's n of them, so each weight is going to be 1 over n. So then we can use the definition of sum. What does sum mean? It means the first exam times its weight, plus the second exam times its weight, plus etc., plus the last exam times its weight. That's by definition of sum. The 3 dots mean etc. And then we can use the distributive property. We have a common factor of 1 over n. We can factor that out outside parentheses. So inside parentheses, we have x1 plus x2 plus etc. plus xn. And then outside parentheses, the whole thing is times 1 over n. And then we can go back to sigma notation again. So x1 plus x2 plus etc. plus xn. In sigma notation, that's the sum as I goes from 1 to n of xi. And then just copy the 1 over n here. And then we can use the rules for multiplying fractions. I put the part that's not a fraction, put that over 1, multiply straight across, and we get the summation equal to the summation I equals 1 to n of xi all over n, and that completes the proof, and that completes this presentation.